All right, guys, today we're going to talk about arcs, semicircles, and central angles. Let's break down some vocabulary to start with. First word we're going to talk about is the word arc. Arc is just a piece of the circumference. And let's go back and kind of break that definition down. Remember, circumference, if we pull up a picture of a circle, circumference is the distance around the circle, so like the perimeter. An arc is going to be a piece of that. So if you think of it in terms of something you're familiar with, think of a piece of pizza. An arc is like the crust of a piece of pizza. It's just a piece of that circumference, okay? The next thing is central angle. Central angle is one that has its vertex at the center. So the center of the circle, and the sides are radii. So if we go back to the picture we were talking about here, the central angle is going to be this angle right here. So because it has an arc and made up of two radii, then that is your central angle. And a way to remember that is the vertex of the angle is in the center of the circle. Now we can break arcs into really three categories. We're going to start with two categories, the minor arc and the major arc. They basically are the names. So a minor arc is one with a measure that is less than 180 degrees. Okay, it's named by its endpoints, and we'll go over that in just a second. So basically where it starts and stops. Endpoints, we know it has to start and stop, which means it would have two letters to name it. Major, obviously if minor is less than 180, then major is going to be greater than 180. Notice I didn't say equal to. That's going to come in a little bit when we learn another word. So minor arc is less than 180 degrees. Major arc is greater than 180 degrees. Minor arc, we use two letters by its endpoints. Major arc has to be the endpoints plus one other point that is on the arc. Okay, so let's break some of this vocabulary down for a minute. Let's go back to our picture here that we're talking about. So a central angle, they want us to name it. Remember, naming is with letters, and I already highlighted your central angle here. If we take two radii, come together in the center, we can see that it's going to be angle LEY. So angle LEY would be an example of the central angle there. Minor arc, we said, is less than 180 degrees, and remember a circle is 360 degrees. So 180 would be the halfway mark. Minor is going to be less than 180. Major will be greater than 180. So minor less than half the circle, major greater than half the circle. So if we look at our picture here, we can see that from L to Y is going to be less than half the circle. So we can write this minor arc, LY, but then we have to put the little arc symbol over it to show that it's an arc. You know, we always label everything. Major arc, we need to include three letters, and it has to be over half the circle. So we could go this direction. There are a couple ways we could probably do that, but this is the one we're going to choose for tonight. So we would connect, just kind of like we do an angle, LUY. We could reverse that too, but I'm going to go LUY. So LUY, and again, because it's an arc, you have to put the arc symbol above it. It looks just kind of like an eyebrow. Okay, the next theorem we're going to talk about, which you already know because we've talked about this many times this year, the sum of the measures of the central angle. So if we put all of our central angles together, it's going to add up to 360 degrees. Okay, now the great thing about central angles and arcs is their measures are the same. Now, I'm not talking about the length of an arc, I'm talking about the degree of it. How much does it open up? So when we look at this central angle here, the measure of this angle, let me zoom in a little bit. The measure of this angle is the same as the measure of the angle of the arc. How much does that angle open up? So let's practice that on a couple of questions here. We can see that If this angle right here is 110, then we could easily find the other part by subtracting from 360. We'll start with that. And so that gives us 250 degrees, so we know that that's what that would be. But I can always go ahead if I want to when I'm working with arcs, is if I know this central angle PCM is 110, then I know arc PM is also 110. Same thing for this part over here with this major arc PNM, I know that it's also going to be 250 degrees. So the central angle matches up with the degree of the arc. So let's answer these questions. Angle PCM we know is labeled already as 110, so that's given. Here's our arc symbol, and because it's 2 letters, remember it's a minor arc, so the value has to be less than 180 degrees. So we can see from P to M, we already have it labeled as also 110 degrees. 3 letters here, we know that that's going to be a major arc, so greater than 180 degrees. We can connect P and M, and again, we already have that labeled, so we can say that that's 250 degrees. Okay, it says what kind of arc is PM? We don't even really have to look at it. We know that there's 2 letters, so that automatically makes it a minor arc. And so the reason, we can say a couple of things. One, it's named 2 letters, so we know that that's going to be a minor arc. We can also see the measure of it is 110 degrees, which is less than 180. So that's another reason that we know it's a minor arc. The degree is less than 180 degrees. Okay, not too bad. Remember, central angle matches up with the degree of the arc. All right, so here's where this 180 stuff comes from. With this semicircle, we know semicircle means half the circle. So it's an arc with a measure of 180 degrees. And it's named by its endpoints and another point on the arc. So we name a semicircle just like we do a major arc with 3 points. So it's really hard to tell. If we have a list of arcs here, it's hard to tell the difference between a major and a semicircle because they both use 3 letters. Minors are still pretty easy to identify, okay? So let's look at this example here. Got a little bit of math to do. So let's go back to our lesson that we talked about yesterday. FD is tangent to circle O. So if this is tangent to circle O and we have a radius meeting at point D, remember we get to go ahead and mark that as 9 degrees. We talked about that yesterday. Then my advice on a question like this is just find all the measures of the missing angles before you even attack this. So we know here, if we zoom in, that this is 9 degrees because of the symbol. We have a right triangle here, so I know that my 2 measures in a right triangle, the measure of the 2 acute angles in a right triangle always add up to 90 degrees. So I can subtract 90 minus 38, and that's going to give me 52. So I know that this angle right here, let me erase this, is 52 degrees. Then that leaves me with 1 here. So I can add all of these up and subtract from 360 because remember that's your total sum every time. So if I add all these up, so we have 45, a 90, an 85, and a 52. If I add all those up, that gives me 272. But remember, we have to take that away from 360. And that's going to give us 88. So that leaves us with that angle there. And you can always add those up and double check yourself to make sure that that gives you 360 degrees. Remember, we just talked about on the previous slide that the measure of the angle is the same as the degree of the arc. So if this angle is 9 degrees, BC is 90 degrees also. They will always match up if your angle is in the center of the circle. All right, let's answer these questions. DOF, so DOF, we found that to be 52. Oops. Okay, EOA, we found that to be 88. And now we have the rest of them as arcs. So AB right here corresponds to this central angle right here, so that's 45 degrees. A to D, so AD is still a minor arc, but do you see how it includes both of those angles? So to find that one, we're going to have to add 88 plus 52. So I'm going to make a note of that. And that gives us 140 degrees. Okay, again, let me make sure you saw that. A to D went here, so we have to include both of those angles. Next one we're going to do is A to C. So now we're kind of going the other way. A to C includes those two angles, so we're going to have to add the 45 and the 90 together, which gives us 135 degrees. All right, BC. BC is pretty easy because it's just one angle there, so we know the arc and the central angle are the same, so that gives us 90 degrees. Now we have three letters. Again, we don't know if it's a major arc or a semicircle at this point, so we can highlight and connect to C. So A to D to C, and you have to go in that order. A, D, C. Well, we can see that that's well over half of the circle, so we know it's a major arc. But we have to incorporate all three of those angles to find the degree of that arc. So we're going to add up those three numbers, 88, 52, and 85. So 88 plus 52 plus 85 gives us 225 degrees. And we can see, yes, that is well over 180 degrees. All right, so next one, ACD. ACD. Now we're going this way, and we have to include all three of those. So we're going to add up a 45, a 90, and an 85 to get the measure of that arc in degrees. So again, we have 45 plus 90 plus 85, which gives us 220 degrees. Okay, last two should be pretty easy. ED, E to D, right there for us, matching up with that angle at 52 degrees. And hopefully AE is the same. Yep, A to E is just one angle, so we just have to bring that number over, and that one is 88 degrees. If I went too fast through this and you need to look back, I will be posting the key so you can go back and check what I did here and what I added up to get those measures. All right, last little bit. Kind of the same process, but instead of just finding the measure, we have to label whether it's a minor arc, major arc, or a semicircle. And I'm going to abbreviate some of that just to save you guys some time. I know just by looking here, if it has two letters, it's a minor arc. So I'm just going to go ahead and get that out of the way. And again, the three letters has two choices, so we're not sure if it's a major arc or a semicircle. Okay, let's kind of dive into this circle a little bit and see what we have. I see a 9-degree symbol, so we can go ahead and put that. Now we have to look here. We need to double check and see if this is a diameter, because if it is a diameter, then that means that that splits a circle in half, and here are your two semicircles. So let's go back to the directions. We can see here that it says that PZ is a diameter, which means it does split that circle in half. So make sure you always read those directions to make sure you have that diameter. Don't assume that. Okay, so if we know that that is a semicircle, then we know that these three together add up to 180 degrees. So I can add up 87 and 38, and that gives me 125. Subtract from 180, which leaves me with 55 degrees for this angle here. Also for that arc, remember those are the same, that's what we're focusing on today. Same thing here, you can add them all up and subtract from 360, but my advice is to just subtract from 180, but even easier, since you have that 9-degree angle, we know that it takes two 9-degree angles to make the 180, so we can just subtract 90 minus 25 instead, and that's going to give us 65. Again, my advice is to always figure out your missing arcs and angles first, because then labeling your answers becomes real quick and easy when you have to add up those things. So let's answer. Here we go. P to N, minor arc PN, we see as 90 degrees. ZQP, so let's highlight that. ZQP connects your diameters, so that is a semicircle. We don't need to add them up. If we know it's a semicircle, we know it's going to be 180 degrees. You're always welcome to add that to check just in case. Okay, RZ. RZ is just one little minor arc connecting one angle, so we know that that's 55 degrees. ZMP, let's connect that one. Z to M to P, so again, another semicircle. We don't have to worry about adding things up. We know if it's a semicircle, it's 180 degrees. All right, RM, meant to erase. RM, we have to add up two angles, 55 and 65. So I'm gonna write that small, which does give me 120 degrees. NQP, so N to Q to P, which a lot of people want to go this way, but remember it's 3 letters, so it's a major arc. We have to go all the way around. Now you can add all those up. I want to simplify it for you, so my advice is to just take 90 from 360, which leaves us with 270. And we know that that's a major arc. It is greater than 180 degrees. Almost there. QN, Q to N. We know not to go this way because that would be over half, so we have to connect this way. So we're going to add 90 and 38, which gives us 128 degrees. And the last one, RP, R to P. Again, it's a minor arc, so we go the short direction, not the long way. Add up 87 and 38, and we get 125 degrees. So, recap a couple of things. Arcs are just like the crust of a pizza, it's just the outer piece of the circumference. Minor arcs are less than 180 degrees, major arcs are greater than 180 degrees, and semicircles are exactly 180 degrees. The last thing that you need to remember from this is that the degree of the arc is the same as the measure of the central angle, and remember, to be central, the vertex has to be in the center of the circle. All right, that's all I have for you for 10-2.